This week, we'll dive further into the evaluation of deep learning models for medicine. In medicine, because the decisions are high impact, we care about understanding exactly when a model works on a patient and when it does not. You'll learn about metrics including sensitivity, specificity, predictive values, and the ROC curve, which are key ingredients in evaluating models in medical settings. In this lesson, we'll talk about the shortcomings of accuracy as a metric. From accuracy, we'll look at how we can derive sensitivity and specificity, two core concepts in medical evaluation. In the second part of this lesson, we'll talk about predictive values, which can help medical professionals with clinical decision making. To answer the question of how good a model is, we'll start by looking at accuracy. When computing the accuracy on a test set, we look at the proportion of the total examples that the model correctly classified. Let's work with an example so we can illustrate the computation of accuracy. Here we have a test set of 10 examples. 8 of them have the ground truth of normal, and 2 have the ground truth of disease. Let's say we have a model which outputs negative for all 10 patients. Negative here means the model is outputting the prediction of normal. This is of course not a useful model, but notice that it's getting all the normal examples right, so it's getting 8 out of 10 examples right, and thus has an accuracy of 0.8. Compare that to Model 2. Model 2 correctly predicts positive on the 2 disease examples here, and also calls 2 of the normal examples positive. Now we can compute the accuracy of Model 2, and if we go through this computation, we'll find once again that we get 8 out of 10 examples right with Model 2 to get an accuracy of 0.8. So we have 2 models with an accuracy of 0.8. Although we haven't formalized this, we get a sense that Model 2 is perhaps doing something more useful than Model 1 because it is at least attempting to distinguish between healthy and diseased patients.